for the Dirichlet box principle, if you want to calculate the Dirichlet box constants, you run Dirichlet box. The verbose procedures gives you a little bit of explanation. So in this case, if you want to work out the Dirichlet box principle constants for pi, you run Dirichlet box for pi. I'm using, so this actually equates to m equals 10 rather than m equals 100 because of the way that Roth stated it, it actually involves square root of m. But it calculates the Dirichlet box principal constants. So in this case, pi you can write as 22/7, and then it gives you the first 10 digits of beta. And this is just a program, we don't necessarily know that that these constants satisfy the conditions. So there's another procedure called check Dirichlet box that when you run, goes through and checks that all of these conditions hold. So first off, it gives you your constants and then runs through each of these conditions one by one. So first off, are these constants equal to alpha? Does alpha equal h over q plus beta? You run the check. It checks it up to 10 decimal places. Obviously, these are real numbers. We can't check kind of for everything, but checks up to 10 decimal places. We check that these two numbers are coprime, so gives you the prime factorizations. We check whether q is less than the square root of m, and finally whether q times beta is less than 1 over square root of m. So this is kind of how I use Maple to help illuminate the proof. I'm going to skip the obvious remarks for the moment and move on to the Maplet. So this is just a demonstration of this feature of Maple called the Maplet. Let's open the screen. So this is what a Maplet is. This is a bit more kind of user-friendly than Maple itself. In this case, we calculate a of k, little a of k, which is its density, and sample a sets. So we're entering a number, in this case 20, and we can calculate all of these features. And it uses Maple, and it's using all these programs that I've already defined, which is why you need to have Maple installed in your system. But it's fairly nice, and you can get it to do things. So if I just clear this, it'll give you data up to the limit of Sloan, so up to 77, although it won't give you an ASEC because it's a bit too big to actually calculate these things. And then if you wanted to be really ambitious and wanted to try 100 million and just plug in all this, it'll tell you, wait a minute now. You're being a little bit too ambitious here. You really should stick between 1 and 77. But this kind of interactivity, I think, makes it a bit less intimidating to use Maple. I know a lot of kind of professors like to do things kind of pen and paper and not necessarily use computers, whereas they don't need to know how to use Maple to use Maplets. So I think this is something that could be used as an explanatory tool, and also in terms of teaching, in terms of for students. Again, students don't need to know how to use Maple to use these kind of things. And I know there are things built into Maple to do with calculus that use similar concepts. And similarly, you can even get it, screen again, you can even get it to draw graphs. So again, this is the graph that I showed before, which in this case isn't that illuminating, but for other things might be. But things like this, we can use Maplets. So this was a neat little feature of Maple that I found. So now back to my paper and talk about interactivity. So this stemmed from a discussion with Dr. Z about how to make Roth's theorem a bit more transparent and a bit more understandable. And I guess the question that came up when we were talking was, what if you didn't need all this further explanation? I mean, there's a lot of steps in Roth's theorem that aren't that clear, but there's some that, if you know a bit about arithmetic combinatorics or about asymptotics, you don't need to explain to you in full. Why would you want to read a full 50 pages when you only need a few little areas explained? So what Dr. Z suggested was the idea of an interactive paper. And to begin with, I created a HTML version of Roth's paper, which I'll show in a moment, that's on my website. And the idea was that if you needed certain things explained, you clicked on them and you got an explanation. And that way you didn't have to read through all the explanation, but anyway you needed further explanation, it was easy to get to. But I did run into a few problems with HTML. I'm not very good at HTML for one, and I found it very hard to work with. Creating math within HTML is pretty difficult. If you try and use built-in HTML, it got very messy. I found a script that you could implement LaTeX into your page, but you had to reload the page. It was pretty slow, and it messed up all my cross-referencing. So I tried to cross-reference in these papers, and when I would cross-reference, when the page reloaded to load all this LaTeX, it would lose my cross-reference. So it really wasn't that useful. So I created this page, and then I kind of thought, well, there's got to be an easier way. So I created a wiki. So what is a wiki? A wiki is defined to be a website that allows collaborative editing of its content and structure by its users. But really what a wiki is Wikipedia. Wikipedia is an online encyclopedia that the users adapt, that the users create pages, the users cross-reference, and it's owned by the users as such. Another example of a wiki is the Polymath project, which was run by Gauss and Tao. I think they've done 5 so far. And the Polymath project was an attempt to prove some mathematical problems through a mass collaborative effort. They got mathematicians from all over the world to contribute to little areas of this proof and to prove one big statement. And I know that the last couple of Polymath projects at least have been done through Wiki form. I can't talk about the other ones because I'm not sure, but I know the last couple have been done in a Wiki form. So I created a wiki, and I created it, at the moment it's being hosted by what's known as a wiki farm, which sounds very exciting, but is actually just a place where you store wikis and they grow, which is hence the name for wiki farm. It's a bit of a problem in the fact that if you go onto it and you're not logged in, you get adverts, and it's non-ideal at the moment. I'm currently talking to the computer department here. You need certain software on your server to run wikis, so I'm currently talking to them about seeing if I can host it here. But how did I create this wiki? Well, the main page is a carbon copy of Roth's paper. And then anytime things like this occur, you can click to another section. So first off, I've split the proof into 6 sections, each of which you can click into to get further explanation. I've clicked links to definitions, references, generalizations, summary, and so on. The advantage is it's much easier to create than HTML. Referencing is pretty much automatic. You put square brackets around the title of a page, and it links to that page. Equations are really easy to program using LaTeX, and it also includes automatic referencing. So, to give you a demonstration rather than talking, let's go here. So my original page, my original HTML page is this one, and you'll see this LaTeX thing gets reloaded, and it wasn't that easy to create. However, my wiki is this one here. And you go into the wiki, and the first thing you want to click on, Roth theorem. You get a statement of Roth theorem, you get alternative statements, and it talks about Roth's seminal paper on certain sets of integers. So you click on this, and you get a copy of Roth's paper. And I've copied it out pretty much word for word. And here's the Dirichlet box principle. For each alpha, there exists HQ such that this holds. And you think, oh, well, I don't know the Dirichlet box principle. Why does that hold? So you click, and you get given a proof of the Dirichlet box principle. And you go through and you read it all, and you're like, okay, that's nice, I understand this now. So you go back up, and you click back on the Dirichlet box principle, and you get taken back to that part of the proof where you were reading where you left off. This goes through the entire paper, and there's some easier statements to understand, some harder statements to understand. Other features of the wiki that are quite nice. For example, here at the end, in Roth's paper, he just states, right at the end, he gives this inequality, so that 49 implies 1. What does that mean? I mean, in the paper, I think, because of the difference referencing it, said something like, so that equation 8 implies equation 1. It's not immediate, obviously, what that means, but with this online kind of interactive paper, you go, okay, what was equation 49? Equation 49 was that b of x is of order 1 over x. What was equation 1? Equation 1 is our original statement of the paper. If you see the equation, you're like, well, I still can't quite remember what that was. You click on it, and it scrolls up to that equation, and it gives you that equation. And it seems like a small little feature, but I actually think things like this really do help understand papers. It does all this automatically, the wiki, and you can also do things like you can hyperlink to other things. So in my list of references, I can link to the actual papers. So if you want to, okay, you want to know about Gauss's proof of Samareddi's theorem, you click on Gauss's proof of Samareddi's theorem, and it takes you to the paper. Obviously, because of journals and things like this, you need to have an account with, in this case, Rutgers or whatever, to use Springer Link. But you can have all this hyperlinking going on. So, just go back. And yeah, so each of these, each page automatically gets tables of contents. If you go to a section, so the adapted hard literal method, you can go to all the explanations for that certain section and read just those, and so on. This is all linked to on my page, and please go and tell me kind of what you think and if there's mistakes for one. I can already see a spelling mistake, so I'm going to go back to my presentation and avoid that. But I do actually think that this idea of having online interactive papers is a really useful one. And I think what would be, first off, I think it would be relatively easy to make all this automatic. LaTeX has a lot of built-in referencing. Wiki code has a lot of built-in referencing. And I think actually it would be easy to create an automatic script to convert LaTeX into Wiki. So first off, I don't think it would be that hard to create these things. But what I think would be really useful would be if there was some kind of central bank of wikis so that you could get interlinking within wikis. Because you have papers that reference other papers, but wouldn't it be really useful if when you got to the point that referenced other paper, you could click and you were taken to that point of that paper with that explanation so that you weren't having to then go, okay, I need to look at this other journal and go through the whole paper until you find the appropriate section, and so on. So I guess that would be where I think it would be really useful. I mean, I think it would be, obviously, you could group things by journals, you can then interlink. But hopefully what this might encourage is a bit more of a kind of explanation. I think a lot of papers now kind of hide a lot of the real method. And this would enable people to still have that very kind of nice, elegant, brief proof, but at the same time have the behind the scenes work and have the kind of explanation of how they got to these results and really kind of help people understand deeply what's going on in these theorems. And that does happen in certain papers. I mean, a lot of papers now have an introduction where they outline their method of proof and then go on to talk about the details. But I do think that this kind of idea of a parallel between your terse, kind of very elegant, very neat proof, and your more explanatory proof would be really something quite useful. But I think it's been useful me creating this wiki. I definitely feel that I understand Roth's theorem more now. But I think it will be a useful idea, and I think to some degree with the internet that we are going to be getting more online papers, and I think this would definitely be an idea that I think will be useful in the future. And I guess that's pretty much it. So
thank you very much.
Any questions?
Thank you for a beautiful talk. Time for some questions?
So for that Maplet, that went very quickly when you
for
k equals 20. Is stuff pre-computed for that? Does this look up on a table?
I think, yeah, I think I use the pre-calculate. I think I just use the Sloan for that. You can get it to run the actual program.
I think you had a sample set that was. You said for at most 24.
24. I think again that was pre-calculated. I think that's all pre-calculated. Okay. I did the map that I programmed last term, and I think it's all pre-calculated. Yep.
To get the existence, don't you need a lower bound?
The existence
of arbitrarily long arithmetic progressions in primes. Don't you need a lower bound? Because an upper bound wouldn't tell you much, right?
True. I'm trying to think of exactly the statement that Greentow gave. So I think that arbitrary comes as a corollary? I'm not entirely sure. I can't think off the top of my head.
If you had a lower bound, then you'd have to use it.
Yeah, true. True, maybe I said that wrong.
Well, do they have lower bounds?
I don't think they give a lower bound in the paper. I don't know. I didn't look into the prime stuff too deeply. I did it just as kind of a tag on to
in general, for the K.
So the lower bounds for the K, right. I think the later papers, so the proof by Gauss and Wolf, talk about K-term arithmetic progressions. Beren's paper is definitely just the 3-term arithmetic progressions, and that's the one that I kind of went through the whole procedure of, but I believe the Gauss and Wolf talks about K-term arithmetic progressions.
Lower bounds.
Yeah, lower bounds on the size of sets. Yep.
So I guess A of 100 is pretty hard to compute because you have to check 2 to the 100 sets.
Yeah.
Has anyone tried like randomly checking a fraction of that to get like a lower bound?
Not that I know of. I mean, I didn't look too much in terms of lower bounds because I was concentrating on the asymptotics. But I guess that would probably be a way to kind of calculate these sample sets and things like this. The problem is, I guess, to calculate this A of x, you do need to check effectively all of them. But no, that would be quite a nice program to program, actually, just kind of finding a random set, checking if it's... But even checking sets that sets avoid arithmetic regressions is in itself pretty intensive work because you have to check for pretty much all the triples that they're not an arithmetic regression. Yep.
Can you automate the Venn theorem?
Yes, I think I can, but I didn't have time by the end of the term to do it. But the construction is pretty simple. So.
Are you planning on doing it?
Maybe over the summer. I'm not got much to do over the summer, so I might implement Beren's theorem and add that to the procedures, definitely. Yeah.
I have a question about the wiki. Is the idea that people will then go in and edit this, or is it like kind of fixed?
So you can. What's quite nice is you can fix pages and you can make pages editable. So what I will probably do will be I'll fix the main page and I'll maybe fix elements of my pages, but then have options for people to add their own explanation or add alternative proofs or add more information about generalizations or add pages. With it being hosted on a wiki form, it's quite nice in the fact that me as the creator have quite a lot of power. So I can approve pages, I can only let people add stuff once I've approved it, things like that. So in that sense, I can keep the main bulk of it kind of static. But yeah, definitely the idea would be that people would then contribute and kind of help explain things. Yep.
Who has the copyright to the wiki? And if Roth is alive, then what does he think of your project?
In terms of the copyright for the wiki, I mean, I guess in terms of my wiki, I guess there's no copyright, as far as I know. There's probably something in
use the Creative Commons licensing scheme.
I guess so. Yeah, I don't know much about copyright law. But in terms of Roth, I believe he's still alive, but I haven't contacted him. I might do. I might see what he thinks. But yeah, I mean, I believe he's still alive, but I don't know how to contact him. So I'll maybe send him a copy. We'll see what he thinks.
Thanks again for a beautiful talk. The next